SMIC 3 nanometers breakthrough, a game changer in the global semiconductor industry. In the ever-evolving world of semiconductors, a new milestone has been reached by China's largest chipmaker, Semiconductor Manufacturing International Corporation, SMIC. Against all odds, and without access to what was once considered essential technology, SMIC has successfully produced 3 nanometer (nm) chips. This development is particularly groundbreaking because it challenges the long-standing belief that extreme ultraviolet (EUV) lithography is indispensable for manufacturing chips at such an advanced scale. The implications of this achievement extend beyond technological innovation. They are reshaping the geopolitical and economic landscapes of the semiconductor industry. The role of lithography in semiconductor manufacturing. To fully appreciate SMIC accomplishment, it is essential to understand the conventional process of manufacturing advanced semiconductor chips. Typically, chipmakers rely on lithography machines to etch intricate circuit patterns onto silicon wafers. The most advanced among these machines are EUV lithography tools, which use extreme ultraviolet light to create incredibly fine patterns necessary for high-performance chips. Dutch company ASML holds a near monopoly on EUV technology, and major players like Taiwan's Semiconductor Manufacturing Company, TSMC, and Samsung depend on ASML machines to produce cutting-edge chips. Due to export restrictions imposed by the United States, SMIC has been denied access to EUV technology. These sanctions were designed to limit China's ability to compete at the highest level of chip manufacturing. However, SMIC did not let these restrictions halt its progress. Instead, the company turned to an alternative approach: deep ultraviolet (DUV) lithography combined with a sophisticated technique known as multi-patterning. How SMIC achieved 3 nanometers without EUV. DUV lithography is an older technology that has been widely used for decades, but has limitations when it comes to achieving the precision required for sub-7 nm chips. However, SMIC found a way to circumvent these limitations through multi-patterning. This process involves breaking down complex chip designs into multiple layers and exposing each layer separately before carefully aligning and integrating them into the final structure. While this approach is significantly more complex and costly than using EUV, SMIC has demonstrated that it is still viable for producing state-of-the-art chips. Additionally, SMIC has incorporated FIN-FET, Fin Field Effect Transistor, technology to enhance performance and power efficiency. FIN-FET transistors, which feature a three-dimensional fin-like structure, increase the surface area available for electrical conduction, thereby improving chip efficiency while reducing power consumption. This combination of DUV lithography, multi-patterning, and FIN-FET technology represents a remarkable feat of engineering and innovation. The geopolitical and economic implications. SMIC breakthrough is not merely a technical achievement, it carries significant geopolitical and economic ramifications. For decades, the semiconductor industry has been dominated by a handful of companies, TSMC, Samsung, and Intel, that control the most advanced chip manufacturing technologies. The United States, in particular, has maintained its technological edge by restricting China's access to cutting-edge semiconductor equipment. However, SMIC's success demonstrates that alternative methods can still yield competitive results, potentially diminishing the effectiveness of these restrictions. This development has accelerated the global race for technological sovereignty. Nations worldwide, recognizing the vulnerabilities in relying on a small number of chipmakers, are investing heavily in domestic semiconductor manufacturing. The U.S. government has allocated billions of dollars to revitalize its semiconductor industry through initiatives such as the CHIPS Act, while Europe, Japan, and South Korea are also ramping up their investments. SMIC's success will likely push China to double down on its efforts to achieve self-reliance in semiconductor manufacturing, further intensifying the global competition. Challenges SMIC faces moving forward. Despite its impressive achievement, SMIC still faces considerable hurdles. One of the biggest challenges is the sheer complexity of consistently producing high-quality chips at scale. Advanced semiconductor manufacturing requires years of research, development, and fine-tuning to ensure stable production yields. SMIC must continuously refine its processes to achieve the level of reliability and efficiency seen at TSMC and Samsung. Another major obstacle is the ongoing impact of U.S. export controls. While SMIC has found a way to manufacture 3 nanometers chips without EUV technology, it still depends on other critical semiconductor manufacturing equipment and materials, many of which are also subject to export restrictions. Developing indigenous alternatives for these components will take time and significant investment. Additionally, scaling up production presents its own set of challenges. While SMIC has demonstrated the technical feasibility of producing 3 nanometers chips, mass production is a different beast. TSMC and Samsung have spent decades perfecting their manufacturing ecosystems, including supply chain logistics, workforce training, and infrastructure development. SMIC must rapidly expand its capacity while maintaining high yields, which is no small feat. The broader impact on the semiconductor industry. The implications of SMIC success extend beyond China's domestic semiconductor industry. If SMIC can scale its 3 nanometers manufacturing process effectively, it could disrupt the global semiconductor market by introducing new competition. This could potentially drive down chip prices, making advanced semiconductors more accessible to a wider range of businesses and consumers. More affordable chips could accelerate the development of emerging technologies such as artificial intelligence, AI, 5G, and the Internet of Things, IoT, spurring innovation across various industries. Furthermore, SMIC breakthrough could inspire other chipmakers to explore alternative manufacturing techniques. If EUV lithography is not the sole pathway to producing leading-edge chips, other companies, especially those outside the traditional semiconductor powerhouses, may attempt to replicate SMIC methods. This could lead to a diversification of semiconductor manufacturing approaches, reducing reliance on a single technological paradigm. The future of semiconductor innovation. The semiconductor industry is at a turning point. SMIC's ability to manufacture 3 nanometers chips without EUV lithography marks a significant shift in the balance of power within the industry. While TSMC, Samsung, and Intel remain dominant players, SMIC's success proves that alternative pathways to cutting-edge chip production are possible. This breakthrough is likely to spur further innovation as companies around the world explore new methodologies to stay competitive. Looking ahead, the semiconductor industry will continue to evolve in response to geopolitical tensions, economic pressures, and technological advancements. The next decade will be defined by a push for greater self-reliance among nations, increased investment in alternative manufacturing techniques, and a relentless drive for miniaturization and efficiency. SMIC 3 nanometers achievement is just one chapter in this unfolding story, but it is a chapter that has already reshaped the semiconductor landscape in profound ways. SMIC's successful development of 3 nanometers chips using DUV lithography, multi-patterning, and FIN-FET technology represents a remarkable leap forward in the semiconductor industry. This achievement defies conventional wisdom, challenges U.S. export restrictions, and signals a shift in global technological dynamics. While significant challenges remain, including scaling production and overcoming ongoing trade restrictions, SMIC has positioned itself as a formidable player in the semiconductor market. As the world watches the next steps in this evolving industry, one thing is certain: the race for semiconductor supremacy is far from over. If you enjoyed the video, don't forget to like, subscribe, and share. Thank you for watching.